and welcome back to Conspiracy Cats, although not really. You see, this week's Conspiracy Cats video is coming out tomorrow. Today is just a little test to see if one of the new style Baldy Cats videos will be suitable for the Conspiracy Cats channel. So please take a look. If you don't like it, let me know and I will just keep them on the Baldy Cats channel. That's it. I will see you tomorrow, but for now, it's over to you, you baldy numpty. Thanks, pal. Anyway, welcome back to Baldy Cats, and tonight's History Revisited is a bedtime story about Olbers' paradox. Now, Olber was a man who asked the question, why is it dark at night? And somehow managed to make the answer very complicated. But before we start with him, we're going to visit some of the scientific geniuses.
Hey, my name's Nathan Roberts.
No, I didn't mean you. Or you. Our story begins with this man, Giordano Bruno. He was killed by the Holy Inquisition for suggesting that the universe was infinite. And that's the end of Giordano Bruno in this story. Turns out he just wasn't that important. But then came Copernicus. Copernicus? Copernicus. Who writes this? He said the sun was at the centre of the solar system. But he was rubbish at maths, and he couldn't prove it. He left that to this guy. Right, sorry, close, man, but I meant Isaac Newton. The church also wanted to kill Isaac Newton for this. That wasn't good.
I wasn't happy about it.
However, they soon realised that an infinite universe could be a universe that was made in the image of an infinite God. So they let him off.
Yay!
So the heliocentric model of the solar system was well on its way to being established, but the question of how big the universe was still a long way from being answered. How big do you think the universe is?
515 feet.
I don't know why I bother. So next up is William Herschel, the guy made famous for his observations of Uranus in 1781. He used a telescope to see faint and mysterious fuzzy things in the sky which became known as nebula. Herschel is often quoted as saying about these nebulae, what the fuck are those things? Well, this question was answered many years later by Edwin Hubble. Edwin Hubble, born on July the 20th of November in 1889. Edwin Hubble was a genius that believed these fuzzy nebulae might be objects that lie outside our own galaxy. But he had an enemy, a man called Harlow Shapley. When Hubble presented his idea that the universe was far bigger than we thought, Shapley quickly and quietly replied, bollocks. So Hubble aimed to prove him wrong, and he used Cepheid variable stars to show that these so-called nebula were too far away to be inside our own galaxy and must themselves be individual galaxies. Hubble then used something called redshift to show how these galaxies are moving away from each other, indicating that the universe itself is expanding. Now, if you don't know what redshift is...
I don't.
Yeah, we know. Now, if you don't know what redshift is, it's basically the Doppler effect with light. You see, when you hear a fire engine coming towards you, you get a very, very high-pitched noise like this.
Yay!
But when it goes away from you, you get a very low-pitched noise like this.
No!
Now, we see the same effect with light from galaxies. If I'm looking at a galaxy that's coming towards me, the wavelength of light in front of that galaxy is going to be shortened as it travels this way. And that's going to make it appear shifted towards the blue end of the spectrum. But if that galaxy is travelling away from me, then the wavelength of light is going to be stretched out, making it appear like it's shifted towards the red end of the spectrum.
Which is, of course, true.
Now, when we look around us in all directions, clusters of galaxies show red shift, showing that they are moving away from us, and that is excellent evidence that the universe is expanding. And also excellent evidence for the Big Bang Theory. Now, the Big Bang Theory was something that Albert Einstein did not believe in. He believed in something called the steady state theory, which stated that the universe had always been there and there was no big explosion. But Einstein met with Hubble and looked at Edwin Hubble's evidence. And when he realised he'd been proven wrong, and the universe was in fact expanding, and there had been a big explosion, the only response Einstein had was to say to Hubble, yeah? Well, your mum's fat.
Boom.
So, with the help of two lovely fellas called Penzias and Wilson, who discovered cosmic microwave background radiation, to be dealt with in another story, the idea of the Big Bang and the ever-expanded universe had been accepted into mainstream science.
Absolute nonsense.
But that is until about 100 years earlier, when a man called Heinrich Wilhelm Olber asked this question.
Can I give a couple of shout-outs?
No, man, they didn't have YouTube back then. I'm trying to read a story. Will you stop interrupting?
Eddie Bravo shouted me out.
Who cares?
What the hell is your problem?
So Olber asked this question. He said, if this is the nighttime sky and the universe is infinite, then it shouldn't matter what direction we look at. Our line of sight will always end up at a star somewhere. Which means when we look in the sky at night, we shouldn't see gaps between the stars. We should just see a brilliant white light, a blinding white light. But we don't.
You know, that's basic stuff, I think.
Now, you might be forgiven for thinking that if the universe was infinite, those stars would be so far away that their light would be too dim by the time it reaches us. But Olber says no, it shouldn't matter how far away those stars are. And he proves it with a bit of clever maths.
Maths proves you're a dick. That's what it
That's
proves.
So let's have a look at the maths that Olber's employed to try to prove this. Olber suggested that this dot here might be the Earth, and that any given distance away from the Earth, we can imagine a circle. And inside this circle, we will have a number of stars.
Okay.
Now, to calculate the number of stars in this circle, he needs to know two things. He needs to know the volume, and he also needs to know the density of the stars, so how many stars there are per unit volume, which is n.
That makes complete sense.
Now, once he's got those two numbers, he can times the volume by the number of stars together, and that will give us an excellent indicator of the intensity of light coming from this region of space.
True.
So an excellent approximation of what the volume of this area of space is going to be the surface area times the thickness. Now, the surface area is going to be 4 pi r squared. And the thickness, I'm just going to call T, capital T.
Absolutely.
Done.
Very clever.
So if I want to work out the number of stars that are going to be in this region, I
300.
can take my volume and I can times it by the density of stars, the number of stars per unit volume. And this will now give me capital N, which is going to be the total number of stars.
Or something like that.
Now, if I repeat this, but I go even further away from the Earth, then I'm going to have a bigger circle, and the volume of that circle is going to be much greater, and it's going to have a lot more stars in it. So you will be forgiven for thinking that the intensity, the brightness of this region is going to be brighter than this, purely because it's got a lot more stars in it. But that's not the case.
And the guy's literally just lying.
And the reason that's not the case is because light obeys something we call the inverse square law, which means if a light source is twice as far away, then it's 4 times dimmer. If it's 10 times further away, then it's 100 times dimmer, and so on, and so on, and so on. So how do we represent that mathematically? Well, we are going to divide, to get the intensity of any region in space, we are going to divide the number of stars by r squared, the distance to it squared. But what that means is, because I have r squared appearing above and below here, I can cancel them both out, leaving me with my final equation, 4 pi Tn, where n is the number of stars per unit volume, T is the thickness of that imaginary shell, and 4 pi is just a constant.
Thinks he's some sort of fucking high level intellect or some fucking thing.
Now this means it doesn't matter how far away from Earth I'm looking. If I'm looking at this shell here, the intensity of light reaching me will be the same as if I'm looking at this shell here, and so on, and so on, and so on. Distance doesn't matter. And because the universe is infinite, and we have an infinite number of these imaginary shells, then Olber could have been right. Why, when we look out at the night sky, are we not blinded by light? And the answer is fairly straightforward and boring. You see, if we fast forward ourselves back into the future, back to Hubble, Hubble has proven that the universe is expanding. And Hubble was able to prove that the further away we are, the faster the expansion is, the faster galaxies are moving away from us. This gives us two effects. The first effect is that light coming from, let's say, this point, has been stretched out through redshift to the point where it's no longer visible light, where it's actually gone from the visible light range into the infrared or even microwave range. So we can't see it.
Does conspiracy catz know he's lying?
But the most important part of this expanding universe is that the speed of the expansion is not limited. Objects can't travel through space faster than light, but the universe itself can expand faster than light speed. And what that means is, once we get far enough away from the Earth, the light travelling from these stars will never, ever, ever be able to reach the Earth, because this region of space here is expanding faster than the light can travel through it. So there we go. So like I said at the beginning of the video, this was just a trial to see if some of the Baldy Cat stuff might be more suitable for the Conspiracy Cats channel. If you think, no, this isn't the kind of stuff you want to see on this channel, fine, just let me know and I will more than happily keep it on the Baldy Cats channel. Yeah, but I will be back tomorrow with a proper, full-on Conspiracy Cats video. Take care, bye-bye.